Right. Okay. So yeah, let's get started without any further ado, guys. Hi, Harleen. I hope you can hear me as well. Good, good morning. Good morning. It'll be a slightly shorter session today, Harleen. Like I was mentioning it to the other students. I have an exam scheduled tomorrow in the morning, certification exam, Splunk certification. So a bit busy with that preparation. So today it's going to be like a small session. Tomorrow onwards, we'll resume our lengthy 1 hour sessions. Okay. So yeah, let's get started. As mentioned, we have to continue on our networking fundamentals topic. We were discussing about the public IPs, private IPs, and the different classes or categories of IPs available. I think we ended our last session on the classification itself. What is class A? What is class B? What is class C? What's the relevance of each class? What are the ranges of each of these classes? We talked about all that in the last session. So class C can connect only 255 devices in a singular network. Class B can connect 255 into 255. And class A can connect 255 into 255 into 255. I hope you can all recall, guys. This is what we discussed in the last class. And we also covered what subnet mask is and what default gateway is. In today's class, I'm going to show you how do you assign a private IP to your system. Now, we all know the public IP is assigned by the Internet Service Provider, ISP. In India, we have ISPs like Airtel, Act Hibernate, Hathway, Tata, or BSNL, etc., etc. Right? In US, you might have ISPs like Verizon, AT&T, T-Mobile, Mint Mobile, etc., etc. Right? Now, when you talk about those public IPs, they are assigned to those ISPs. But when you talk about private IPs, those are in your control. You can assign them yourself in your network. Okay. So if you have 10 devices in your network, you can assign each unique device a unique IP of your choice. Okay. But again, please note if you want them to communicate with each other, they should belong to the same class, the same network. Okay. Now, I've already shown you how to check your private IP. Okay, and to assign your private IP, there are two methods. One, you can assign it manually from the control panel, or two, you can get it automatically from a DHCP server. Okay, now, right now in my system, if I check my private IP, it is 192.168.0.3. This is a Class C private IP that is being assigned to my system. Okay, and right now I'm getting it automatically. Okay, let me show you how I can tell you that. Okay, so as mentioned, there are two methods to assign a private IP. One, you can get it assigned from the control panel. You can manually assign it yourself. So if you were the network admin for an organization and it were your responsibility to see to there's connection enabled between all the devices in the network, you would go and assign each device a unique IP. So to every system, you'd go to the control panel one by one. And in the control panel, you select network and internet. In that, you go to network and sharing center. In that, you have to click change adapter settings. And whichever adapter you want to connect to the network, you right click on that, go to the properties, select IPv4 properties or Internet Protocol version 4. And here you can see there are two methods. Currently, I'm getting the IP address automatically. Okay, so I'm getting it assigned by a DHCP server. But if I had to assign it manually, I can select the second option and manually start typing the IP address here. Currently, I was getting 192.168.0.3. But if I had to change that, I can give something like 0.100, let's say. Okay. Subnet mask. Now you know what subnet mask is for class C. It is 255.255.255.0. Okay, that's the value which tells that this belongs to the class C range. Default gateway is your router's IP. We all know the first IP in the network is the router, as discussed in the last class. So I assigned 192.168.0.1. So that is how you have to manually assign an IP if you had to do it for n number of devices. So for each device, you would assign a unique IP address here. Okay. And along with this, you also have to assign something called a DNS server address. Now, don't worry about the DNS server. I explained this as well, but not today. We'll talk about it tomorrow because it's going to be a slightly shorter session today. Okay. But just in case if you didn't know what to assign here, you can go to your browser, and in your browser, you can just do a quick search, Google DNS server IP. So when you search for that, oh, sorry, Google DNS server IP. So when you search for that, you get two IP addresses. One is 8.8.8.8 and the other one is 8.8.4.4. And you can assign any one of those here. 8.8.8. Oh, my numlock is off my button. Or 8.8.4.4. Okay. Even if you assign one of them, that's completely fine. Okay. So this is important for you to be assigned so that you can connect to the internet, guys. I explained why and what these addresses are in the next class. Okay. But for now, if you don't know what to assign here, you can just search for Google DNS server IP and you can assign those addresses here. And as soon as I click OK, my system's IP will change from 192.168.0.3, the existing one, to this new one, 0.100. Okay. I would not do that now because again, if I do so, your connection to my system would be lost and you would have to reconnect again. So again, we would lose the connection, the meeting. So let's not do that right now. But you can try this out on your system, guys. No harm in this. Okay. And if you had to revert it back, you can just select the first option again. Obtain an IP address automatically, obtain a DNS server automatically. And that would just revert the previous state back. Okay. So that is how you would assign the IP manually to your system. So if you were the network admin for an organization, and if you have to assign IP addresses to each system manually, this is the same exact procedure that you would follow. Control panel, network and internet, network and sharing center, adapter settings, right click on the adapter, properties, IPv4 properties, and you assign the IP. You assign the IP address, the subnet mask, and the default gateway. And under that, you assign DNS server addresses as well. Okay. Quite a lengthy procedure, but that was what was done in the earlier days. Okay. So was someone asking a question?
Yeah, just
Yeah,
do we get the recording of the session? Because I don't know, my internet is fluctuating, so it's just on and off. So
you
will
have
get
you're
a
registered for this course, Deekshita?
Yeah.
Yeah, you'll be getting it on your Gmail directly, on your
Oh,
Google Drive. You'll get the
oh,
recordings, nothing to
oh,
worry.
thank
Okay, right. So again, as mentioned, this was the method to assign it manually. Now, if the network is small, it's if you have 10 devices, 20 devices or so, this is quite an easy method. It's not that big of a task. But let's say if you have hundreds of systems in a network, in such a huge network, a network admin going to each device and assigning a unique IP might be a time-taking task. Okay. If it's a class C network, you would have to go for two. Again, you'll have a maximum of 255 devices there. So even for that smaller network, it's quite troublesome. Like if it's class B or class C, that's even more hectic, right? That is why people invented something called a DHCP protocol, Dynamic Host Configuration Protocol. Okay. So from the name itself, you can figure out what it does. It is basically if I go to the next slide, one second. Yeah. So as mentioned, a DHCP server is capable of automatically assigning an IP address. So from the name, you can understand it is to dynamically or automatically configure an IP address to every host. That's what DHCP stands for, Dynamic Host Configuration Protocol, DHCP. Okay. So it is to dynamically or automatically assign an IP address to every device or configure an IP address to every device in the network. Okay. Now, how does that happen? How are you getting this IP address automatically? So now this is how it happens. So there's something called a DORA process, and a DHCP server has a pool of IP addresses. So it has a list of IPs, and from that list of IPs to every system connected in the network, it assigns a unique IP to each device. And the process through which it allocates it is called the DORA process. Okay. Now you might have a question, where is the DHCP server in our home network? The Wi-Fi router. So your again wireless fidelity. I think that's the full form for Wi-Fi. So wireless fidelity or Wi-Fi router basically is the device which acts as a DHCP server as well. It's the same thing. Okay. If you have to confirm that, you can just go to your command prompt. And in your command prompt, I think you can run the command Windows for CMD, and in CMD I can run a command ipconfig/all. And you can see over here in ipconfig/all, you can see this is your DHCP enabled setting, which means in my network, the DHCP server is enabled. And my router default gateway here itself is acting as a DHCP server as well. So both the devices are same. Okay. But what do I mean by DHCP server and what is this DORA process? Let's talk about that. Okay. So first things first, let me draw this out in a very simple diagram. So as mentioned, in our home networks, let's assume we have the Wi-Fi router here, which is also acting as a DHCP server. Okay. And this has a pool of IP addresses. Okay. So if this is the first IP, you have the pool of IPs from this again, pool of IPs or free IPs. Okay. Something like 192.168.0.2. Then you have 192.168.0.3. Then you have 192.168.0.4. This goes on until 192.168.0.255. Okay, but you never assign that last IP. I'll explain why. There's a reason for it. This is called the broadcast IP. This is also commonly known as broadcast IP. Okay. Now I'll explain what that is in a minute. Don't worry. Okay. But now let's say there are multiple devices in the network. And if they're connected to the DHCP server, your DHCP server will automatically assign an IP to each of these devices from the pool. And the process through which it allocates it is called the DORA process. So here we have 192.168.0.2, let's say. And here we have 192.168.0.3, let's say, assigned. Okay. As soon as those IPs are assigned to these devices, they are removed from the pool because you should not assign the same IP to another device. So 0.2 is removed and next IP starts from 4. Okay. Now, let's say I get one more device in the network. So let's say there's another device connected. Okay. Now let me explain what this DORA is. So firstly, this device, when it is connected to that DHCP server in the network, okay, let's say you bring a LAN cable or you enter the Wi-Fi password. As soon as you enter the Wi-Fi password in this device, the first thing this device does is it starts sending something called a broadcast signal. Okay, a broadcast signal is something which is sent on the broadcast IP. So this device gets the broadcast IP first. And from this IP, when a packet is sent to this IP, it is basically sent to every other device in the network. Okay, sending a packet to this one IP sends it to all the other devices in the network. That's what broadcast IP is. Okay, and this packet is called the discover packet. Okay, so a discover broadcast signal is sent. Okay, so it's asking every device in the network, are you the DHCP server? Are you the DHCP server? Are you the DHCP server? So it's trying to discover who the DHCP server is in the network. It's asking every system, I'm new to this network. I want to get an IP. Can you let me know who the DHCP server is? Can you point me to the DHCP server? Okay. So when it reaches these other devices, when they're not the DHCP server, they just reject that packet. So they don't respond to it at all. Okay. But when it reaches the correct DHCP server, that server responds back saying, hi, you have reached me. And now for this discover, I can offer you an IP address. So whatever next available IP is there, that is offered to the client. Now for that offer, your client says, hey, thanks for offering me that IP. I request you to allocate that IP to me and do not assign it to anybody else. Okay, so since you have offered me, assign that IP directly to me. If there's any other new device in the network, don't assign assign this IP to anybody else. I want you to reserve this for me. And for that request, finally your server says, okay, got it. I understood that. And I acknowledge that. Okay, so there's an acknowledgement, a confirmation saying, hi, I've got your request. I assign this IP to you. And this is my acknowledgement or confirmation. And with that acknowledgement, this device gets the IP 192.168.0.4. And as soon as it is assigned here, it is removed from the pool here. So 4 is removed. And then you're starting from 5. Okay. And this entire process is called the DORA process. D for discover, O for offer, R for request, and A for acknowledgement. So no matter how many devices you connect in that network, you don't have to assign an IP manually yourself. As soon as it is connected in the network, it communicates with the DHCP server and gets an IP automatically. Okay. Now, when does this happen? You might have a question. So if you remember, I'm not sure if anyone has noticed this ever or not. Whenever you connect a device to the Wi-Fi router, let's say in your phone, when you enter the Wi-Fi password and as soon as you click connect, you see a message first. Before it shows connected, it shows another message, obtaining IP address. I'm not sure how many of you have ever observed that. So I think it's very popular in Android phones. Not sure if it is visible in iPhones also or not. But that message, when you see obtaining IP address, that's where your phone has authenticated with the router after entering the correct password and it starts the DORA process there. Okay. As soon as the DORA is initiated, after the DORA is completed, you get the message connected. So in that short time span, like maximum half a second or so, this DORA happens in the background and your system gets an IP automatically. Okay, so that's what DORA processes, and this is how the devices and the network can get IPs automatically. Okay, is that clear, everyone? Pradeep, Chaitanya, Narendra, Jamal. Hey, Jamal. I think this is your first session. Hello, guys. Can you hear me? Okay, others. Jaya, Haleen, any questions? Okay, perfect. So yeah, that's about it for the session today, guys. Again, as mentioned, apologies for the shorter session today, but we're going to resume tomorrow with a much lengthier session. As mentioned already, I have an exam tomorrow, this certification exam. Once I'm done with that, I would be a lot more, I would have a lot more time to focus. And yeah, that's it. Any questions or doubts before we exit the session today? Pradeep, any questions? Chaitanya, any questions? Jamal, any questions? Narendra, any questions?
No from my side.
No.
Oh yeah, Pradeep, you're saying something. Okay, assuming no questions, everyone. And yeah, that's that. We can exit the session here, guys. Apologies for the shorter session again. My bad. I could not inform you earlier. And again, I don't have the emails of everyone yet, guys. So there's still the confirmation list is to be sent to me. So once I get that, I can create a WhatsApp group. And on that WhatsApp group, I can inform you prior, just in case if there's any interruptions as such. Okay. So tomorrow we connect back and we will complete the entire remaining networking concepts left out. I think there's only a few more topics left out in networking. We'll talk about what DNS servers are. So DHCP is done. We'll talk about DNS servers. And after DNS servers, we have one last topic called special IPs. That's it. Okay. This will conclude the entire networking topics. Right. After that, we'll be getting into something called lab setup installation, a very important topic actually, where I'll show you how do you install virtual machines. Okay. So we have these other virtual machines to run or install for our lab setup, Kali operating system, Windows 10 or Windows 7 or any of these Metasploitable. So I'm going to show you how to install this application called VMware, a virtualization software within which we can run other operating systems like Kali, etc., etc. Okay. So we're going to talk about that in the session tomorrow. Tomorrow's session is going to be very interesting. It's going to be a practical session, one of our first practical sessions. Okay. And it's going to be very important as well for the entire duration of the course. So please do join tomorrow without fail, guys. It's a very important session tomorrow. Okay. So yeah, that's it. Nothing further. We can exit the session and connect back tomorrow at the same time. Bye-bye. Have a good day.
Thank you. All the best, sir.
Thank you, guys. Bye-bye. Thank you again. Thank you, guys. Thank you. Bye-bye.